Welcome, ladies and gentlemen. Today we're going to be addressing our sound waves notes. We're going to go through this just like last time, line by line down our page. First thing we're going to address is that sound waves are also more commonly known as mechanical waves, which means that they can travel through a medium. Sound waves cannot travel through a vacuum like outer space, means they must have some form of matter in order to transfer the energy. We're going to draw what a longitudinal or a compression wave looks like in the box to the right. I've put two different options for a longitudinal or compression wave. You can choose to draw either one. I recommend drawing both. That way, if you see something like this on a unit test, you know both of these can represent your longitudinal or compression wave. So in the first one, we can see the different dots representing our atoms or molecules and how the wave is traveling through those. In our second one, we have the lines representing the different parts of the wave. Both of these represent the mechanical wave or the wave that's traveling through the matter or the medium. It's just different representations of each. Again, you can choose to draw one or the other, but I recommend drawing both. In some areas of the wave, the molecules get bunched together, and we can see that in our picture. We call this area of the wave compression. And in other areas, the molecules become spread out. We call this rarefaction. So it is kind of a funny word, rarefaction, but it does just mean the area of the wave that is spread out in a longitudinal or compression wave. Next, we're going to look at the basics of sound. This tells us that the speed of sound is how fast the wave or vibrations pass through medium or matter. The type of matter has a large impact on the speed at which sound will travel. Oh, looks like we lost it. There we go, a large impact. Sound does travel faster through water than air. This happens because the molecules are more tightly packed together. So the more packed together the molecules are, the faster the sound can travel. Looking at pitch and acoustics, frequency is how fast a sound wave is oscillating, which is different from how fast the sound wave travels through the medium. A sound wave with a low pitch and a sound wave with a higher pitch in each of the boxes below is going to be represented by the two pictures. So that low frequency means we're going to have a longer wavelength. It's going to take us a little bit longer to get from crest to crest or trough to trough. So there's our low pitch. We can see the first crest, and then we actually only get two crests in this box altogether, versus our higher pitch where we have 1, 2, 3, 4, 5 crests in this box. So that's that frequency they're talking about. That will complete your notes for today. Thank you very much for watching.